What's up? It's your man Jimmy Chan. Alright, here we go about LabWork 6. Let's start with number 1. Alright, so number 1 says that f of x is equal to these two equations here. It's x plus 4 when x is less than 1, and it's negative 1 when x is greater than or equal to 1. I think the more I thought about it, the more I help other students, what I realize is that maybe the best thing to do is actually just to create a table. Okay? So back in the day when you guys create tables, it looks something like this. Okay? So here is my x values, here's my y values, and what I notice is that right here it tells me which equation to use depending on the x value. I'll use x plus 4 when x is less than 1, and I would use y is equal to negative 1 when x is greater than or equal to 1, okay? So what I'm going to start with is saying, okay, I'm going to try to use some points that are less than negative 1. Less than 1, so I'm going to start with negative 1. So let's say negative 2, let's say. Negative 1, 0, 1, and 2. Let's go 3. What the heck? Okay? So with that being said, let's extend this all the way down. And let's extend this all the way down. There we go. All right. So, in fact, what I'm going to do is I'm going to put another 1 in here as well. And you're going to be like, why? The reason is because right here, what I notice is that everything that's equal to 1 or greater, okay, is that I'm going to use the equation y is equal to negative 1. While when x is less than 1, I'm going to use the equation. Wow, that looks really nice, doesn't it? That y is equal to x plus 4, okay? And then there's this one here that I haven't dealt with, and the only reason why I'm using it is because it's kind of between, but not, right? So what I do know is that with that being said, that at this one here, we're going to have an open circle when I'm dealing with the x plus 4. But while I deal with this one right here, I'm not just going to deal with an open circle, but I'm going to deal with a closed circle. Okay? So, let's take a look. So, at negative 2, I'm using y equals x plus 4. So, this is going to be negative 2 plus 4, which is going to equal to 2. This is going to be negative 1 plus 4, which is equal to 3. This is going to be 0 plus 4, which is equal to 4. And then at 1, if I force it, then that would be 1 plus 4, which is at 1 plus 4, which is equal to 5. And that's going to have this open circle. Okay? And then once I switch over to 1, real 1, okay, when it equals to 1, is actually going to use the equation y equals negative 1. So, negative 1. Well, at 2, y is still equal to negative 1, so negative 1. And at 3, y is equal to negative 1, so it's going to be negative 1. So, this is actually a horizontal line, because y equals 1 is a horizontal line that goes through y equals negative 1. So if I was to graph this, Here's my y-axis, here's my x-axis. So if I look at this, it says that at -2, it's 2. At -1, it's 3. At 0, it's 4. And at 1, it's 5 with an open circle. Okay? All right. Now, then, at 1, it's -1, but with a closed circle, and then 1, 1. I mean, -1, -1, -1, -1. So here to infinity, let's try that again. Here to infinity is going to be just a horizontal line. But before that is going to be this line here, because it's less than 1, it's going to be that line right there. So with that being said, this is going to be choice D. There we go. Okay? So that's number 1. Number 2. Hopefully that will help with it, because it seems like that most of our issues is with this piece right here, right? I'm not sure what to do with that. And I'm thinking that building a table will probably be the easiest way to do this. So that's what I'm going to say is the best thing to do. All right, so number 2. Number 2 has this graph, and I'm going to try to recreate this graph here. So my main points here is -2, -2. And then I have a point that is -1, 2. Then I have another point at 1, 2. Then I have another point at 3, -1. And then it goes on forever there, and it crosses for 0. So let me draw this. And then there's this little curve here that crosses. Whoopsies. I said 3, 1. There we go. And then we have this that curves through that. And then we got a straight line here. And then we got a straight line here. There we go. So we got something like this. So what you notice is asking for increasing. And so what I notice that is increasing from here to here. And it's increased from here and beyond. Okay? So what that tells me, if I'm looking for the interval, right, that's increasing, then I'm really looking for the x values that's increasing. Okay? So with that being said, the first interval where it's increasing is really from here to here, okay, which is really -2 to -1, and then next time it's increasing from here and forever, okay, which is 3 to infinity. So therefore my interval would be from -2 to -1, and these are always open intervals, union with 3 to positive infinity. All right, and that is going to be choice A. There we go. All right, to number 3. number 3. All right, so this wants the difference quotient. Okay, and difference quotient is something that you should know, should remember. Okay, and this is f of x is equal to 1 over 2x. Okay, so given the fact that I have f of x, I also need to know f of x plus h, which tells me that what I need to do is wherever the x is in f of x, I got to replace that x with x plus h. All right, so that means this is going to equal to 1 over 2 times x plus h. Okay, great. Well, I know that the difference quotient says what? Difference quotient says f of x plus h minus f of x all over h. Okay, well that's going to equal to, okay, that's going to equal to that, which is 1 over 2 times x plus h minus 1 over 2x, right? Because f of x plus h is 1 over 2 times x plus h. All right, so that means I need to take this and move it up just a tad so you can actually see all of that, all over h. Well, I have 2 fractions on the top, right? So let me do this really quick. Take that, duplicate that, and bring it down. So since I have this fraction on the top, what I need to do to combine it is to get common denominators. So asking what do they have that I don't have? Well, the first fraction doesn't have an x that the second fraction has. And the second fraction is missing an x plus h that the first fraction doesn't have. Okay, so with that being said, let's see. So if you look at just the bottom right now, okay, both denominators has a 2, an x, and an x plus h. So that means I keep the bottom. So let me draw a fraction here. So the bottom has a 2x and an x plus h. All right, so the top, what does it have? It has an x minus an x plus h. Okay, and then I have all of this all over h. Okay, so what do I really have on top? I have an x minus x minus h, because I have to distribute that negative through. Okay, all right, so that is over 2x times x plus h all over h. Okay, so that means I have a negative h over 2x times x plus h all over h. Now, I have a fraction divided by a fraction. So I need to do copy, change, flip. So I have a negative a, copy, change, and flip that 1 over h. Flip that h over 1, it will become 1 over h. And if you notice, the h would cancel out, right? So my final answer is going to be a negative h over just a 2x times x plus h. So that would be my answer right there. And that, oops, sorry, no h's left because it was canceled out. So that, however, would be B. There we go. All right, so that's number 3. All right, off to number 4. Do I have enough space for this? Yes. All right, so I have a 0.52, and it needs to be perpendicular to the equation y equals 1/3 x plus 3. Well, in this equation, the slope is equal to 1/3. What I really need is a slope that is perpendicular to the 1/3, which is flip and negate. Okay, so flip and negate. That means the slope perpendicular is going to be a negative 3 over 1, which is just negative 3. So that's the slope I'm going to use over here. So now I can forget about this now. Okay? I don't need that anymore. All right? So now I can use the y equals mx plus b to find my b. So that means my y is 2 is equal to negative 3 times 5 plus b. So my b is going to be a 17 because negative 3 times 5 is negative 15. Add the 15 over to a 2 will give you a 17. So therefore, my equation is going to be y is equal to negative 3x plus 17. And that is going to be choice A. All right. There we go. And I haven't even looked at the answer key yet. So let me see. I have dab. I dabbed. I got a dabba. Okay, so dabba is correct. All right, so off to number 5. Okay, number 5. Number 5. So my f of x is equal to 5x plus 7. Okay. So, again, I'm going to go ahead and make a table. And you're going to be like, what? All right, so I know that x sub 1 is equal to negative 1. And x sub 2 is equal to 0. Sad part is, I already know what the slope is. So, let's make a table. So, here we go. Boom. I got this. I got this. All right. So, I have my x. All right. And I got my y. So, my x is negative 1. That means I got to do 5 times negative 1 plus 7. And that's going to give me a 2. And when I put in 0, I got 5 times 0, which is 0, plus 7 is going to be 7. Then, the average rate of change. Just means slope. So, here we go. This is going to give me 2 minus 7 over negative 1 minus 0. So that's going to give me a negative 5 over a negative 1, which is equal to 5. So my average rate of change is 5, which is choice B. There we go. A little crooked. But here's the thing. Remember how I said I already knew what the slope was? Isn't that right in the equation? Y equals mx plus b. Things that make you go, All right, to 6. I know that song is way before your time. All right, number 6 gives you f of x to equal to 6x minus 4, and g of x is equal to 8x minus 9. And I want you to find f composite g of x, which really means f of g of x, which really means f of 8x minus 9, because g of x is already defined. It's right here. It is 8x minus 9. So now, when I look at just this piece right here, what is it really saying? It's saying, hey, use the f function, which is right here, right? And wherever that x is, replace with 8x minus, sorry. I'm not looking for that. Let's rewind. We're looking for f minus g of x. So that means f of x minus g of x. Okay? So, what is f of x? F of x is equal to 6x minus 4 minus g of x, which is 8x minus 9. Sorry for the confusion. We've done so many composites, I thought maybe we were going to do a composite again, but no, this is subtraction. So, this tells me that what I'm going to have now is this 6x minus 4 minus 8x plus 9. Correct. I do need to distribute this negative through. Okay. So that is what I'm going to do, and that's what I did. So therefore, I'm going to have a negative 2x plus 5, which is choice B. All right. There we go. On to number 7. Number 7, the famous number 7. F of x is equal to x minus 5 squared when x is greater than or equal to 5. Okay? So, as I've done so far, I've done a lot of tables, so I'm going to do a table here as well. All right, so here's my x, here's my y. All right, so x is, so I'm looking at this right here. This is telling me what x values to use. It says use x values that are greater than or equal to 5. Awesome. So then I'm going to start with a 5, then a 6, then a 7, then an 8. And you guys can't disagree that those numbers aren't greater than or equal to 5, right? So let's plug those in. So with 5, I'll have 5 minus 5 squared, which is 5 minus 5 is 0. Squared is still 0. 6 minus 5, which is 1, squared is 1. 7 minus 5, which is 2, squared, and it is 4. And then 8 minus 5, which is 3 squared, which is 9. Right? So those are my points there. So I have here, this is I might as well get this part done. So, there we go. So, what my points are is this: 5, 0, 6, 1, 7, 4, and 8, 9. Okay? So now what do I have to do? I got to find f negative 1. Oh, that's a little big. F negative 1, which means what? Inverse. And what do I do with inverse? Switch x and y. Okay, so let's switch x and y. So now the 5, 0 is going to become 0, 5. What's going to happen when 6, 1? 1, 6. What's going to happen with 7, 4? 4, 7. And what's going to happen with 8, 9? 9, 8. So this red that you see here would be my dotted line. And this black point here would be my solid line. So whichever one goes with that is my answer. Now, the question is, which one? Because I really have two answers here that have the same exact graph, which is A and C. Okay, so if I was to, let's go ahead and just graph this a little bit here. Two, 4, 6. Whoa, I made this really big. Let me see. 2, 4, 6, 8, 10. And I'll go a little bit further. Then I'll just do this right here. Okay. So let's plot these points. 5, 0. 2, 4, 5, 0, 6, 1, 7, 4, and 8, 9, 4, 6, 8, 9. So really my solid, if I can draw it correctly, would look something like that. Okay, and now let's plot the red points. 0, 5, 1, 6, 4, 7, and then 9, 4, 6, 8, 9, 8. Is that point right there? Okay, so my domain and range for this point right here is going to be, which is my black line here, is going, my domain is going to be from 5 to infinity. While my range, that's my range. It's going to be from 0, my domain. Nope, that's right. Why am I questioning myself? It is from 5 to infinity. My range is going to be from 0 to infinity. And then the domain and range for my red points, the domain is going to be from 0 to infinity. And my range is going to start at 5 and it's going to go to infinity as well. Okay? So the question is, which of those choices are correct? Which is really choice C. And there we go. All right, so that's 7. So do I have enough space for 8. Let's just go to the next page. Just poops and laughs. Okay. So 8 says f of x is equal to 4 over x minus 6. And g of x is going to equal to 4 over 3x. Okay? Now this one, however, does want the composite f composite g of x, which really means f of g of x, which really means f of 4 over 3x. Okay? So if we look at this right here, actually, let me do it this way. This right here really means that right there. So f of 4 over 3x just means find the f function, which is here, and replace the x with 4 over 3x. So I'm just going to replace that x with that. Okay? Awesome. So if that's the case, let's come back over here. Well, let's see what that equals to. That's going to equal to 4 over, replacing the x with 4 over 3x, and then it's going to be minus 6. So again, when I look at the denominator, what do I have here? The denominator has basically two fractions, right? What I can think of the 6 is that I can say that 6 is just 6 over 1. So that means I need common denominator. What do they have that I don't have? Well, the left denominator has 3x. The right denominator does not have a 3x. So I need a 3x, and I got to multiply top and bottom. So I still have that 4 up top. And the bottom now, if you notice that if we look at the bottom, they both have a 3x now. So we're going to keep that 3x. And the top is going to be 6 minus 18x. So again, still, I can look at this a certain way as well. I can look at this as the division of two fractions. So what I would do is copy, change, and flip this 3x over 6 minus 18x. Okay, so when I multiply fractions, what happens? I multiply straight across. So I'm going to have a 12x over a 6 minus 18x. Really, there is a way to reduce this even more because there's a number that goes into 12, 6, and 18. However, this choice is already there, which is really choice A instead of the reduces. So here's my choice A, and that would be my answer at this time. The answer is choice A, and that would be my answer at this time. There we go. All right, so number 9. All right, number 9 says that f of x is equal to 4 over x plus 7. And g of x is equal to x plus 2. All right, so it wants me to find the domain of the composite, which is f composite g of x, which as I told you before is f of g of x. Okay? Which means f of x plus 2. X plus 2. So what I'm really doing is wherever the x is in the f function, right? So let me go back here. So this f is telling me to recall this function right here, okay? And then what I have to do is wherever the x is, replace it with that piece right there, okay? So that's what I got to do. All right, so if that's the case, then I have a 4 over the x plus 2, then plus the 7, which I really have a 4 over an x plus 9. So that's my final equation of the composite of f of g of x. So since I'm looking for the domain, if you guys remember about fractions, is that I cannot let the denominator equal to 0, right? So that means what I would do as a sidebar is saying that x plus 9 cannot equal to 0. So what would that make it? So x cannot equal to -9, which means that I can use everything else except for -9. So if that's the case, then my domain would be from -infinity all the way to -9, but not including -9, union with not -9 all the way to positive infinity. So that would be my domain, and that is choice A. And there we go. And there we go. All right, so on to number 10. All right, what does number 10 ask for? Number 10 is wants you to find the inverse of f of x is equal to the square root of x plus 5. Okay, so if you guys looked at the inverse, it tells you to replace the f of x with y because it means the same thing. Then the next step is to replace the x and y. So I'm going to have x is equal to the square root of x, the y plus 5. And then to solve for y again. So in order to do that, I'll have to square both sides. So I'm going to take this, duplicate it so that you can see it. So I got to square both sides. So now I have x squared is equal to y plus 5. And I got to subtract 5 from both sides. So I have y is equal to x squared minus 5. Which means that f -1 of x, which means inverse of the function f of x, is equal to x squared minus 5. Which is choice A. There we go. All right. I think we have a decent sized video here of everything for LabWork 6. So hopefully you guys have been starting on the LabWork already. On the review already. And if you have any questions on these, please let me know. See ya. Bye.